Hello and welcome to my channel Physics with Fun. Here we will discuss about the very basic concepts of the physics. Today we will start our next unit, second of class 11th, which is kinematics. So let's start first chapter of unit second, which is motion in a straight line. Let us first discuss the introduction of the chapter motion in straight line. Statics and dynamics are the two main branches of the mechanics. Statics is the study of the object at rest, or we can say that the study of object under the effect of force in equilibrium, whereas dynamics is the study of object in motion. Motion of object is studied under two separate things. First is kinematics and second is dynamics. Kinematics is the study of the motion of the object without taking into account the cause of their motion, whereas dynamics is the study of the motion of the object by taking into account the cause of their change of state or their motion. Our next concept is rest and motion. An object is said to be in motion if it changes its position with respect to its surrounding with the passage of time. On the other hand, if an object does not change its position with respect to its surrounding with the passage of time, it is said to be at rest. Our next topic is motion in 1, 2 or 3 dimensions. To define motion in dimensions, we need to know first coordinate frames and coordinate points. In mechanics, the position of an object in space is specified with the help of a set of three mutually perpendicular lines, and these perpendicular lines called coordinate frames. As shown in this picture, the point P represents the initial position of an object while the point Q represents its final position. Both the positions of the object is fixed in the space with the help of a set of three distances x, y and z along x-axis, y-axis and z-axis respectively. These are called the coordinates of the point. The change in the position of the object with the passage of time means the change in the values of x, y and z with the time. The position of the object changes due to a change in 1, 2 or in all of three coordinates. Now let's see what is one-dimensional motion. If only one of the three coordinates required to specify the position of the object in space with respect to time, then that motion called one-dimensional motion. In such a motion, the object moves along a straight line. For example, motion of a train along a straight line, a man walking on a road, and any object falling freely under gravity. Next is two-dimensional motion. If two of the three coordinates required to specify the position of the object in space, then these motion are called two-dimensional motion. In such a motion, the object moves in a plane. For example, the earth revolving around the sun and water falling from a pressurized pipe. Let's see what is three-dimensional motion. If all of the three coordinates required to specify the position of the object in space, then these motions called three-dimensional motion. Such a motion is not restricted to a straight line or a plane, but it takes place in a space. It is the most general form of motion. For example, flying kite, a flying bird, and a flying aeroplane. Our next topic is difference between path length and displacement, or we can say that difference between distance and displacement. We can define path length as the distance covered by the object in a given time. In path length, we do not consider the direction of the motion of object, and the displacement is the distance covered by the object in a particular direction. Displacement has both magnitude and direction, and hence it is a vector quantity. And as the path length does not has direction, that's why it is a scalar quantity. As shown in this picture, AOB is the actual distance that object covered. This called path length. And ACB, the shortest distance called displacement. We can also define displacement as the shortest distance between the 2 points. So that's all for today. Rest of the chapter we discuss in our next video. Thanks for watching.